All right, uh, so with the same graph, okay, same graph and same curve, but this time, all right. So by this time, uh, okay, the same curve. All right, by this time, we use instead of we have we have fx, instead of we have f if instead of we have same from A to B, but each fringe we have a point which is x1, x1, x0, x1, x2, x3, and until xn. Xn and xn plus 1. Alright. So each of the fringe, we split into the fringe, but by this time we put a point in the for each fringe. Alright, so before that, like I mentioned before this, the derivative of x actually is equal to b minus a over n. Alright, b minus a over n. Alright, so this is b. There is the total, actually the total of the range, actually the range from b to a, actually, and then over with n. Alright, n is the number of fringe, actually. So this is the number of fringe. Alright, so instead of we use the derivative of x, we use h. Alright, so alright, so for x naught, we use x naught is equal to a. So x naught is equal to a. We know that the point of x naught is equal to a. Alright, then for x1 is equal to a plus h. Alright, and x2 a plus 2h. So we can know the pattern here. All right. So that's mean when x n equal to a plus nh is n equal to 0, for n equal to 0, 1, and 2. So we can have this equation. All right. From this series, actually. From this series we can have this equation. All right. All right, then we want to find the whole area. All right, so that means you need to uh, you need to this is from the sine area equation. So that means the h here, instead of we use the derivative x here, we use what we use h. All right, we use h. All right, so f x here is the x naught here is the for each point, the curve for each point. So you can find times with h here, then you will get the area for each fringe. So this means you find the area for each fringe. Then you add up all the fringe, then area of all the fringe, then you will get the area, the total area from A to B. All right. So that's mean instead of we use the derivative x, right? We use now we use a numerical. That means from n0 here until n minus 1. So instead of we use h, instead of we use a derivative x, we use h here. All right. So this is the equation for the sine area. But instead we use alphabet or derivative x, we use h or n numbers here or series. All right. Sine area is the basic, actually. It's the basic for the integration. All right. So it's basic for the integration. So from the sine area equation, we we can find, which is the limit derivative x to until approaching to 0. So we, instead of use we use integration curve or integration symbol. We use integration symbol to replace the limit and the summation. Actually, this is the make it the equation much more uh, easy, all right, to write, and then easy to solve, all right. Okay, so also for 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 the for the definite integral, right? So that means you have a range, so certain range or limit. All right, so that means from B to A, or from A to B, you will find the area. So that means you have the fx here. So fx here, we have learned in the entire derivative in the last chapter. All right, so that means the f you need to integrate, and then you will find the fb minus fe. Definite integral. All right, so definite integral. Okay, so for the definite integral, so this means you have and the indefinite integral. This means for this in this chapter, so let's assume that when you assume that the function doesn't have a limit, that means it's infinite. So assume that the function doesn't have a limit, so it will become the antiderivative fx. So does this mean that you don't need to find the area itself? The area itself is we do have the limit for the area itself. All right. So we don't need to put the limit. So for example, like find the antiderivative of x cube. All right. This means the x cube is x4, x3 plus 1 here, and over with 3 plus 1. This means x power of 4 over 4. You don't forget to put c here. So c is the constant, because when we integrate, right, if we have a constant, we will we become 0. And then when we to try to find the antiderivative, we will assume that it has a constant. But we don't know the constant, but we just put the letter c here. And then what about the antiderivative of cos x? All right. So this means, see, this one is you need to refer from the antiderivative table that we do in the last chapter. All right. Okay. Thank you.